Welcome, tech enthusiasts and security aficionados. We're delving into the intricate world of cybersecurity in this video to uncover a prevalent threat, XXE injection. Picture this, a seemingly harmless input on a web application. But lurking within lies the potential for exploitation, causing havoc in the form of XML External Entity attacks. But fear not, as we're not here just to identify the problem. Prepare to journey with me as we unveil the dark arts of XXE vulnerabilities, decode the intricate maneuvers of Java-based defense, and emerge empowered to shield our digital realms. This demo program is dedicated to shedding light on XXE vulnerabilities, as mentioned earlier, using Java as the primary language and Eclipse as the IDE. It aims to elucidate how a program, seemingly innocuous, can inadvertently pave the way for XXE exploitation. Throughout this demonstration, we'll unravel how hackers utilize XML techniques to exploit XXE vulnerabilities, and, most importantly, how to fortify against such attacks. In this video, I'm jumping right into the action with a Java web program. That's all about showcasing the nitty-gritty of XXE XML External Entity Injection and its solution. No beating around the bush, I've designed this web app to walk you through 4 different scenarios, plus a slick move of disabling DTD right by the submit button to fend off those pesky XXE injections. That's right, we've got a total of 5 scenarios to unravel here. First up, we kick things off with a live demo of how the program smoothly reads the string inside a foo tag, using an XML parser and displays it on the web page. Now, let's dive into demo number 2. If you've been around the XXE injection block, this one might ring a bell. The program, this time, reads the foo tag string but with a twist. It's got the XML parser poking around the system32 directory for the host file, passing that content and XXE. Hit submit, and you'll see the content of the host file. It's like peeking behind the curtain. Moving on to demo 3. I switched things up by trying to read an HTML file. Here's the catch, DTD fails when it encounters certain characters. So, I give you a sneak peek at the contents of this HTML file. Looks like a regular HTML file, right? But when we submit this XML, bam, the program hits us with a SAX exception. Curious about the characters causing this hiccup? Well, even if they're tricky, hackers can still find a way to snatch your files. Now, the 4th showcase aims to demonstrate reading that HTML file. I tweak an XML, making the foo tag display file contains. But, surprise, the DTD above doesn't have file contains. You see where this is going, it's all in the evil.dtd. Let's peek inside, shall we? File points to the same HTML from the previous demo, used in all. Then, start and play the CData trick, neutralizing special symbols from file. Back on the web page, we witness XML using %DTD calling evil.dtd, then using %all to generate file contains. And voila, we successfully read that HTML file. Hit submit again, and voila, success again. I use the browser's view page source to showcase the HTML content we've captured. Then, I showcase another HTML, a telltale sign of what I'm aiming to demo, a combo of XXE injection and XSS. I'll let you take a look at the HTML file content. We're going to demo this time. I go back to evil.dtd, point file to this HTML. Back to the web page, and submit the XML. See, hackers won't rely on just one vulnerability. You might have thought XXE injection only meant them swiping some non-critical files. But when combined with XSS, it's trouble. If you're not sure about the impact of the cross-site scripting, check out my other video on it. Lastly, I demonstrate whether shutting down DTD fixes things. Submit, the program indeed can't run DTD. Straightforward, right? Stick around, there's more to uncover. Next, Let's explore whether this approach is also applicable to exploit hack 1. Following that, let's delve into the program and understand why it is susceptible to vulnerabilities, and how disabling DTD prevents the program from causing XXE injection. The program is straightforward. If you've ever written a similar piece of code, you'll grasp it at a glance. The program relies solely on a checkbox to toggle DTD. Yes, just these 3 lines of code to disable DTD. Simple, isn't it? Furthermore, let me show you the report generated by Fortify after scanning this program. Fortify indeed detects XXE injection issues. The window at the bottom left tells you all the steps involved in generating XXE injection. To pass Fortify with this vulnerability, you only need to modify the code from line 113 to 120 to retain only the code between lines 114 and 116. I set a breakpoint at line 107, entering debug mode. You'll gain a deeper understanding of how the program triggers this vulnerability. The program stops at line 107, then at line 108. It reads whether DTD should be enabled from the checkbox. I paused at line 109 to let you see whether the values of the XML and checkbox read at this point match our expectations. At line 109, a document builder fake object is created, and we check if XML is correctly loaded. Lines 113 to 120 determine whether to disable DTD. Subsequently, we acquire the document builder object. Parse XML at line 123, obtain the element object at line 126. Print some data for debugging at line 128, and finally, at line 129, print to the web. Moving on to debugging the vulnerability in hack 1. The program halts at line 109. Take a look at the value read from the web. Then, let the program run to line 129, and you'll see that the value parsed from XML is the content of the host's file we've already reviewed. I continue to the next debug. First, I check the Disable DTD checkbox, then submit. The program again halts at line 109. Now, DTD is enabled, altering the program flow. The program proceeds to line 114 to disable DTD. Eventually, an exception is thrown at line 123, demonstrating the entire disable DTD process. Displaying exceptions directly to the user is not a good practice. It makes it easier for hackers to attack your system. In conclusion, I leave the glory of success to you. You can test whether disabling DTD resolves your XXE injection. Once your program passes the application security test, this victory is yours. Some might wonder, what if I need to use the DTD functionality? My advice is, unless you are familiar with DTD and fully understand how hackers exploit XXE injection for attacks, it's better not to enable it. In most cases, not using DTD can still achieve your goals. If you do have a legitimate reason to use DTD, scrutinize every detail to avoid becoming a target for hackers. That concludes today's discussion on XXE injection. If my video has been helpful, please like, subscribe, share, and don't forget to hit the notification bell. Thank you for your support.